Hi everyone, welcome back. So today we'll continue with the multilinear regression, and in this video I will explain how to build and measure a multilinear regression model. And the first step is my extract data. For extracting data, I will import pandas as PD. This pandas will read the data from the CSV file data variable which stores the data read from the CSV file pd dot read csv. Within double quotes, I will paste my file location. In the path, you have to give double slash to consider the slash data dot head, which returns the first five rows. Python environment, kernel detected, conda environment, and now I am having the multiple independent variables. What are those? Let's see what we will get. It is still connecting. Once it is connected, it will go into execute. So these are the column names: R&D spend, administration, marketing spend, state, and profit. Okay. So I will check first what are the null values present or not. I will check whether the any null values is there or not, missing values. And here profit is my dependent. Sorry, profit is my y, and independent will be state, marketing, speed, administration, R&D spend. And we have to consider whether it is considered as the independent or not. For that I will explain you in the eda. Okay, so in the eda explanatory data analysis, I will initially check whether it contains null values or not. Is null dot sum. If I run this, okay, there are no null values. Let's take the get the information. Okay, float object. So I have to consider change it to float. In the initial simple linear regression, what I told is if you there is an object, then you have to convert into integer or float type. Data dot describe. Okay, so these are the description of the data frame. Okay, now in the next step I will use the feature extraction, but before that I have to change this object to float or integer type. How can I do that? For that, from scalar dot pre-processing import label encoder. Now take LE as reference for label encoder. Now label encoder will change the this categorical variable column as the integers. So I will take as state, or we can use -2 also, no issues. Data of is equals to le dot fit transform data of state. So if I check the data dot head, did you see? Earlier it was the string, and now it converted to integers. One. What does it mean? Means this one is mapped to one v- value. That is Florida. Florida considered as one, and two is mapped with New York, and California with zero. So it is mapping with the integers. So finally we have converted it. Conversion done. Now before cutting the feature extraction means x and y, I will check whether the data is exactly correlated with dependent variable or not. For that, I will import cborn as SNS dot pair plot for data. So it will give me the linearity or not. If it is linear, then it is considerable. Else, not considered. If you want to see the correlation, if it is near to one value, then we can consider data dot correlation and not equals to. Okay, but I'll explain. So if you see this graph, it will give me the linearity graph. So profit and R&D spent is linearity because it is something in the straight line, looks like in the straight line. And administration is something is scattered, and the state is linearity, but it is something exactly not which is in the categorical 0 1 2, and in the market expertise it looks like something linear. So if I consider this and this, the model will be good, and I should not consider profit because profit and profit is always one. So let's see the correlation. Okay, so this if this is my y, and my independent variable will be R&D because it is nearest to 1, 0.9, and 0.2. I think we can also consider, but model will be not good. Okay, we can consider, and which is 0.1. It is very bad, but which is not exactly dependent on this y. So I will consider the x as data dot index location starting from all including all rows for except -2, because I will not consider this profit, I will not consider this state, but rest of everything I will consider. That's why -2. So -2 means excluding state, I will consider everything from this side. Okay, I got it. Now in the dependent variable data dot index location, in, consider all rows and only the last column dot values values. If I check the values for x, print x. Yes, I got it. Print y. Okay, so now I have to scale the features. For the scaling the from scalar dot preprocessing import standard scalar. I will take as the reference standard scalar, and I will apply this to this x. So before that, I have to give train test split. I have to split the data from sk learn dot model selection import train test speed, x train, x test, y train, y test equals to train test speed for x and y. With the test size, I will use 30% of the data as test set. So remaining 70% will be my training set. Done. Now I will use xtrain replace with the standard xtrain dot fit transform xtrain. In the same way for the test also, sa dot transform x test. Okay, so now in the model building, I will take linear regression from scale learn dot linear model import linear regression, and model will be linear regression. Now I will fit this model to the training set. Model dot fit x train comma y train. Okay, good. So till now what I have done is I have checked the correlation with the y, and if it is nearly to the one, the profit is exactly dependent on the independent variables. And in the feature scaling, I have first splitted the data as x train and y train, x test and y test, and this train test split will divide the data set into two types, two halves, where it consider as half part will be for the training, half part will be for the testing, and those values will be stored in these variables. And I will fit the standard. I will do the standards scaling for extrain and extras to handle the data frame of the training and test set. And in the model building, I will use linear regression to fit the model, which having the multiple features and one dependent feature. So here I am having the multi-linear regression model. It has been initialized. So next step I will do the evaluation. So for the evaluation, I will to consider the metrics from sklearn dot metrics import R2 score, mean absolute error, squared error, and some mathematical operations for the numpy as np. So my test accuracy or score equals to model dot score x test comma y test, train score equals to model dot score x train comma y train, print testing score test score, print train score train score variable. Now mean absolute error, mean absolute error for y predict. So I will consider y pred equals to model dot prediction for x test underscore test, and I will check the mean absolute error between y test and y pred. So in this y pred, I will having the predicted values for the x test. I will complete now. I will take the absolute error between the y original values and predicted values. In the same way for MSc, mean square error, mean squared error, I will take y test, comma y pred, root mean square RMSc equals to np dot sqrt for MSc, print MAE, mean absolute error value will be MAE, print. Okay, so this will be MAE, print MSc will be my MSc, print RMSc will be RMSc. If I want to see the what is the R2 score also, y test, comma y pred R2s, print R2 score will be my R2s. If I run this, I got this. This is a testing score of 0.88, training score 0.97, and absolute error, squared error, root mean square, the R2 score. So if I want to know what is the coefficient also, we can also find. So coefficient means C. In the line equation y equals to mx plus c, I will find C. What is the intercept? So for that, intercept, intercept or coefficient, COEF, intercept or coefficient. Okay. For that, model dot coefficient, and I will have the slope also. Slope equals to model dot intercept, print inter CEPT or constant will be my COF, print slope values, slope values, which will return array of integers. Why? Because in the multilinear regression I am having the multiple independent variables. For each independent variable I will having the individual slopes. Okay, slope values are slope. If I run this is my const. Okay, okay, sorry. This is this are this is the intercept, and coefficients are slopes. This is what I have. Okay. So just a small recap once again. I'm having the multilinear regression. Y equals to mx plus c is my simple linear, and y equals to m1 x1 m2 x2 plus c. So this is the my multiple linear regression where m1 m2 are the slopes and x1 x2 are the independent variables. And I have then the extraction of the data, and checked whether it is null values or not, and got the information about the data frame. In the data frame, I am having the object, so I have consider changed it to the integers by mapping the numbers using a label encoder, and feature extraction. I have plotted the pair plot for check the linearity, and correlation. For correlation, I have used the heat map and annotate with the value annotate for seeing the correlation values. So I found that in the for the profit, the R&D administration and marketing speed are nearly to one. So I have considered these three only. So I have taken x and y variables for independent and dependent. And in the feature scaling, I have first step is my to uh, split the data as training set and test set, and using standard scalar on independent variables. And for the model building, I have taken the linear regression from linear model, and I have applied the evaluation metrics. And now this is my steps to find the what is the slope of the multiple lines, multiple features. So this is my slope, and this is my intercept. This is how you can find the values. That's it from me. Thank you. If you have any doubts, pin me in the comments.